Welcome viewers, in this video we will see the solved problem based on the measure of trigonometric ratios sin theta, cos theta, tan theta, cosecant theta, secant theta and cot theta. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. The given problem is if tan A equal to 2 by 3, then find the all other trigonometric ratios. So in the problem, the tan A value is given, that is 2 by 3. By using that, we need to find the remaining ratios, sin theta, cos theta, cosecant theta, secant theta and cot theta. Now from this tan theta, tan A equal to 2 by 3, we know that tan theta is nothing but the formula is opposite side by adjacent side, that is 2 by 3. That is opposite side is 2, adjacent side is 3. So the given value tan theta is given 2 by 3. By using that, we need to construct the triangle. We need to see the values. What are the values are available. Now construct this triangle PQR. At P, the angle A is available. Right? We can draw the triangle at any model, but it should be a right angle triangle. The naming also anything, but here is given as PQR. Right? So the angle is available at this. At point P, angle is available. We can place the angle here also. That's no problem. But here it is placed at point P. So based on this angle, where the angle is available, that opposite side is the opposite side of angle A. QR is the opposite side. Opposite side means opposite side of the angle A. So this PQ is automatically adjacent side of the angle A. Right. Then this PR is the hypotenuse. So in this problem, we have PQ is adjacent side, QR is opposite side, PR is the hypotenuse. In this problem, the tan theta is given, that is opposite side by adjacent side 2 by 3. So opposite side is 2, that is QR value is 2. Then adjacent side is 3, PQ value is 3. So we got these two values, right? PQ is 3 and QR is 2. In order to measure the other trigonometric ratio, we need the hypotenuse also. We need the value of PR also needed. So before going to the ratio, first we will find the value of PR, hypotenuse, by using the Pythagoras theorem. Based on the Pythagoras theorem, PR equal to square root of PQ square plus QR square. That is, this PR square equal to PQ square plus QR square. So that PR equal to square root of PQ square plus QR square. PQ is nothing but 3 is given. QR is nothing but 2. So 3 square plus 2 square. 9 plus 4, 13. So PR equal to square root of 13. Now we calculated the hypotenuse value also. Right? So in this problem, tan theta, tan A is given. By using the tan A, we constructed the angle, triangle. From the tan A, we come to know the adjacent side value as well as opposite side value. By using the Pythagoras theorem, we calculated the other side. Remaining side is the hypotenuse. That value also calculated. Now we know the value of opposite side 2, adjacent side 3 and hypotenuse square root of 13. So by using the value, we can find the remaining trigonometric ratios one by one. First we will find the sin theta. So these are all the values. Opposite side is nothing but QR, that is 2. Adjacent side is PR, that is 3. These two values are already given in the problem itself, tan A. From that we calculated, by using Pythagoras theorem, we calculated hypotenuse PR, that is equal to root 3. So that we can go for the trigonometric ratio. First sin A. Sin A is opposite side by hypotenuse. The formula is opposite side by hypotenuse. Opposite side is QR. Hypotenuse is PR. That is 2 divided by root 3. Right? Opposite side is 2, hypotenuse root 3. So 2 divided by square root of 13, not root 3, square root of 13. Then cos A is adjacent side by hypotenuse. Adjacent side is 3, hypotenuse is square root of 13. Right? Adjacent side is 3, hypotenuse square root of 13. Then cosecant A, tan A is already available in the problem itself. tan A is given, from that only we calculated remaining value. So cosecant A is nothing but reciprocal of sin A. Sin A and cosecant A are reciprocal. So that it is hypotenuse divided by opposite side. Here opposite side by hypotenuse, here hypotenuse divided by opposite side. So that square root of 13 divided by 2. Here 2 divided by square root of 13, here square root of 13 divided by 2. Then secant theta. Secant theta is the reciprocal of cos A. Secant A is the reciprocal of cos A. Right? So that it is hypotenuse divided by adjacent side. Cos A is adjacent side by hypotenuse. Secant A is hypotenuse divided by adjacent A. So that square root of 13 divided by 3. Here 3 divided by square root of 13. Here square root of 13 divided by 3. Then cot A. Cot A is reciprocal of tan A. Tan A is opposite side by adjacent side. Cot A is adjacent side by opposite side. Adjacent side is 3, opposite side is 2. Adjacent side is 3, opposite side is 2. So 3 by 2. So in the problem it is given 2 by 3. Tan A equal to 2 by 3. So automatically cot A reciprocal we got 3 by 2. Right? So in this problem the tan A value is given. The tan A is nothing but opposite side by adjacent side. By using the right angle triangle we calculated the hypotenuse value by using the Pythagoras theorem. So two values available in the problem itself, tan A opposite side and adjacent side. Hypotenuse calculated from the Pythagoras theorem. So by using these three values, opposite side, adjacent side and hypotenuse, the trigonometric ratios are calculated one by one. Sin A, cos A. Tan A is already available in the problem. Then cosecant A, secant A and cot A. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.